Guys, welcome to St. Miss Online Tutorials. On today's episode, we'll be discussing on momentum and collisions. Welcome back. There are many questions involving forces that cannot be answered by directly applying Newton's second law. For example, when a truck collides with a car, what determines which way the wreckage moves after collision? We will find in this video that we don't have to know anything about these forces to answer these questions of this kind of nature. Our approach is to use two new concepts which we know as momentum and impulse, and also conservation of energy. So with that being said, let us discuss on momentum and impulse. Now, according to Newton's second law, we know the summation of the force is equal to mass times what? Acceleration. This is in terms of the work energy theorem. This is in terms of what? The work energy theorem. But let us look at the second law in terms of momentum. That is to say, let us consider a particle of constant mass. But we should remember that acceleration is equal to change in velocity over what? Change in time. This is representation in particle form. So with that being said, now if you impute this into this, you have your change in force, summation of force, should be mass times dv over what? Dt, which gives us d dt open brackets mv. So now we can now say that the rate of change of mv is called momentum or linear momentum. We can now represent this now with this. This is in the particle form. Now Newton's second law now becomes summation of force now becomes dp over dt. Now this is it. This is we representing it in the linear or in the moment or in the rate of change of momentum. We also have an equation we'll be using, and we call this equation impulse. Let me write this up. We also have the equation we're going to be using. We'll be calling it impulse. Now this impulse can be represented as J and is equal to force times change in time. Force times what? Change in time. Now let us compare momentum and kinetic energy. Let us see how they have to come about, because when the example we gave, we said when it went to collision is being occurred or is being happening. You know what I'm saying? Between truck and a car. So let us now compare momentum and what? Kinetic energy. Now here's an application of the distinction between them. Now let me give you a very classical example. Now suppose you have a choice between catching a 0.5 kilogram ball moving at 4 meters per second, or a 0.1 kilogram ball moving at 20 meter per second. Which one will be easier to catch? You know both of them have the same magnitude and momentum, right? If you multiply it, this is mass velocity. You have 0.5 multiplied by 4, and it's still equal to 2. And you also have 0.1 multiplied by the 20, it's still equal to 2. So they have the same momentum and what? And magnitude. Now however, the two balls have different values of kinetic energy. Remember, kinetic energy from primary school have mv what? Squared. Now the large slow moving ball has a kinetic energy of 4. That large slow moving ball has a kinetic energy of what? 4. But the small fast moving ball has a kinetic energy of 20 joules. You can see the massive difference. So now for you now to catch this ball now moving at this speed, you must have to lean back 5 times the way you lean once you want to catch this one. Like if you want to catch this one, if you divide it, you find out that this is 5. So for you now to catch this one, you have to lean back 5 times the amount you use in catching this one, or else you might just get yourself injured. Let us study an example. Now the example said two gliders move toward each other on a frictionless linear air track. After they collide, glider B moves away with a final velocity of 2 meters per second. What is the final velocity of glider A? Let us solve. Now let us say this is the first glider moving the second glider. So now the S component now of this total momentum is equal to this. Remember we said our momentum is mv. Now the S component is equal to m a for this one. Let us say this is a and this is b. For the first one we have m a v a what x, that's on the x axis. Let us put our 1. This one is for this particular one, and that is equal to, so we have to plus it. We'll get this one and get this one. We're talking about the S component before collision. This one will now be mb vb, write this vb 1x. Now calculating that we have 0.5 multiplied by 2 plus 0.30. The magnitudes are not given. So let us say our ME is equal to what? 0.5, moving at a velocity of 2, and our MB is 0.3, moving at a velocity of what? 2 also. That is going to be a -2. Let us see how this moving at -2. Let us see how that will come. Remember why I said -2 is moving toward this direction. This gives us, if you do your maths correctly, you should be having 0.4 kilogram meter per second. So now we've gotten the final velocity after and before they collide, and this is positive. Do you know why? Because glider A has a greater magnitude of momentum before the collision than does glider B. So if it collide with it, since we have a positive figure here, that means that the glider A has a greater magnitude before collision than glider B. So now we have to get the S component which after the collision. The speed is equal to mv. This one now will be MEVA2x. This one is after collision plus MBVB2x. So now what we need to get now is to get our VA what? 2x. That is the collision after the what? The speed which leaves after the collision for the first one. We'll get the second one also. But to get VAX, we have V2x, which is equal to remember from our question, we say that glider B moves up with the final velocity of 2. Don't forget. So what we need to get now is our what? The velocity at which glider E moves off. So we have 0.4 minus 0.3 is a minus, then the 2 which it moves off with, divided by the mass of glider E, which gives us -4 meters per second. So now the final speed at which this glider A moves or switch, it's going to be negative. So what this means is that before it collides, the magnitude was positive, but after it collided, it moves this way. Glider A moves this way. Do you understand what I'm saying? Because as glider A is coming this way, after it collided, glider A moves this way, glider B moves this way. Do you understand what just happened here? That's just a practical way of solving stuff like that. In the next video, we're going to be talking on elastic and inelastic collisions and momentum conservations and collisions. So I'll be dropping a comprehension for you to understand more of these terms. Goodbye.